hey, let me just show it off. So totally open for this to go any way we want. All right, so I'm going to bring up my cloud machine, and here we go. So this is the reference architecture that I pretty much model my commercial software off of. So these are my internal playgrounds. Some people in the community have access to them, some don't. But basically what I've got here is easy. And then I have another one, which is a monorepo for pure convenience sake, where I've got a shop app, a home app, a checkout app. And when I merge anything here, Versal goes and kind of turbo repo diffs each of these subfolders to see if any code changed with the main branch. If it has, it'll run the build on one of those specific ones. But keeping everything in a monorepo, everyone kind of thinks, oh, you're not really deploying independent repos. It's all in a monorepo, so the CI is waking up and rerunning everything. So to prove the independence of it, I just said, cool, well, for convenience, here's the main one I work on, and then here's another separate repo, different build pipeline, completely disconnected from the main application that I usually work in. So what I'm pretty much doing with all of this stuff is, the idea is module federation works really, really well on the client side. Super intuitive, works out the box, all of that. It begins to fall over when we get to the server. And this is for a handful of reasons. The one main reason that it falls over, hold on, let me share my screen. So the one main reason that it starts to fall over on us is, well, how do you pipe code into Node in the first place? The second thing that starts to come up is, okay, well, if I figure out how to pipe code into Node at runtime, what happens when you update the federated module? How does Node magically know that it needs to re-require this? Same with Webpack. When you do a dynamic import, if I have it in a map where I'm going to dynamically import some component and I loop over that dynamic import 100 times, you don't see the network go and download the same thing 100 times. It gets it once, and then it recycles what it already has in the graph. So now when we say we have a living application that I essentially need to hot reload, what do? How do we update the server with remote code without tearing down the Lambda or without doing a rolling restart across the whole server, purely because we need to, wipe the web. We basically just need to restart Webpack. We don't need to kill the process or anything. We just need to reboot Webpack so that it restreams or reads the code off of wherever it's from. So those were the two primary challenges that we ran into. I saw someone had their hand raised, so please jump in here. Nobody?
Hello.
Yeah. Hey.
Hey, what's up? I'm just want to ask you about a question about a book.
Yeah.
The Amazon architecture, writing the building
micro front ends.
Yeah, building micro front ends.
Oh no, it might blur it out.
Yeah, I can see it. Is it really the source of learning micro front end, or just any other?
So what I would say about so there's been like one or two pieces of feedback that Luca got about it, where people were under the assumption that building micro front ends was how to build a micro front end. That's not exactly what the book is about. The book is more about, well, how do you think about software so that you can build micro front ends? Because there's a million ways to skin the cat, but how do you do it in a scalable enterprise grade manner? So and it covers module federation, single SPA. I think it might even cover like iframe style. It covers state management, communication between them, and any type of pattern, browser events, basically anything. How do you stitch together things on the server? What do you need to think about? Blast radius, canary stuff. So it's a very, very good thing if you need something on architecture where you don't want to like stumble across all the problem areas, it's a very good shortcut to go and get all the strategic thinking and know some very well-tested, solid patterns to then choose how to proceed forward on building your micro front end on whichever technology you would want to choose.
So you mean this isn't specifically about module federation? This is more like building micro front end, a stack, kind of like.
Yeah, it's building micro front ends, and in there's a whole. I mean, I don't even know how long the chapter is. I haven't fully read the book, but let me. Like when I got the book, I got all excited, and I literally just opened a page, and the first page I opened was literally my API for Module Federation. So there's a whole chapter and interviews that we've done, and it's pretty much like all of us, like me, Joel Denning, all the big micro front end guys pretty much went and gave input on what do we see, how do we view the world, and what are our opinions. And Luca compiled all of this on top of his experience in building really big at-scale microsystems, and pretty much compiled it all together using subject matter experts on everything. So there's a whole chapter here. Yeah, okay. Micro front end. So then so there's about 40 pages, I believe, just on module federation. If I'm right, there could be more in here. I'm just looking through the index here, but there's a whole chapter on module federation that takes you through, here's how you wire it up, here's some patterns, here's things to watch out for. It also grades everything, so ease of use, reliability, so you can get a feel for, okay, well, what's a 5 out of 5, what's a 4 out of 5, from complexity, scale, orchestration, learning curve, all of that stuff. So it's all included in here, but it's not a book about module federation. But module federation is definitely covered in here, and it's very meticulously reviewed from, somebody who's not really biased towards one solution or the other. It's, I'm a principal architect at AWS. How do you build scalable, independently deployable systems? Here's the tech on the table. Here's my opinion of it. Here's the pitfalls that I've seen.
Yeah, I used SingleSPA recently, and I watched the SingleSPA workshop. It's like 2 hours course in SingleSPA, but we are using Next.js in our company, and definitely SingleSPA is not the choice for our solution. But I'm definitely following along the discussion on Next.js module federation, but it seems it just it's a stale, and we are not going to see module federation in Next.js anytime soon, I think.
Maybe not native support, but this is the other nice thing about, or why I love Webpack so much, is if you are motivated enough and if you know the API well enough, there is no framework that can stand in the way of the compiler. When you get to the compiler level, the compiler is the be-all and end-all of anything that you want to do. So whether the framework supports it or not, that might matter at the framework level or at the surface level. But if you have power over Webpack, every piece of code that it compiles is purely pseudocode. It's up to the compiler to decide what that code is actually going to become. So if Next never supports it officially, that doesn't concern me at all. I have control over Webpack, and I can make Webpack make it work. If that makes sense.
Yeah, but the default, like the default assets, they are kind of forcing the assets and underlying Next, and collision between assets when you have multiple Next.js app or multiple, for example, one Next.js app, collision with other Next.js app JSON files and pages, and it's just really hard to.
That's a good point, and this has been a problem with it. Is if you try to just say, well, I just want Next to say render a header, even if you can get like a render API where it spits back the markup, it's not going to spit back what you want. It's going to spit back body, HTML, documents. So you have to regex, rip everything off of it, pull out the piece that you want, and then it all still looks for Next data. So the serialization method, there's no way to break into it and reroute it to say header next data. So, it's not very good at mounting multiple things on there unless you start really hacking so there is a hack that you can do. I've done it once before. Pretty much you put an inline script at the top that you pretty much you monkey patch document query selector, and you replace next data ID with a proxy object. So then whenever someone tries to go and JSON parse the next data script, what they actually end up getting is your proxy, and you can determine, okay, who's asking for it, and I can change what the data is, and I could kind of reroute who's going to parse next data programmatically by overriding the DOM. So if I get in front of the DOM, then it doesn't matter what's on the page. I'm sitting in front of the document. I can control what document create element means, or what query element by type, or So it's a bit of a hack, but it is a way to kind of get around it. And it's definitely tricky, though. It's not straightforward.
I definitely asked a couple of times to Next.js team, just leave an option for prefixing assets, or just no defaults, or find out give us some API to handle underline and underline Next.js, or it's even the underline Next.js is a force, and just so hard to maintain
So I will show
Next.js
you
federation.
a trick that I've come out with, which might help you. But before I switch branches here, I am going to quickly just demonstrate locally doing a hot reload, or locally I'm changing federated code, and I'm going to hot reload it. And because I don't want to switch branches and then switch back and all of that. But
Sure.
basically, what I've got here is this is the home app that I'm under. So this is inside of home, components, and then I've got header. So I'm going to do something simple like make the background green. So now I'm going to go to the checkout page, which runs on port 3000. And if I go into app, you'll see that I've got header, just like that. Now, I spoke a little bit before about the whole concept of component level ownership and component level data fetching. And that's a concept that I apply to the header, because now the header needs to get API data from somewhere. So do I either have to say, take the header and couple it to get initial props, or can I have it be as simple as I just put header on the page, and the header server and client will retrieve its own data. So how that looks in component level ownership is inside of my header here, inside of the home app, I have load shell data. Then I get the shell data that I want, which is, shell data, header menu, and that will return items. And then, down here, I'd pretty much go, cool, if there are items, then, if items exist, map over the items. And now the nice thing with that is it means I'm completely uncoupled. So now this is self-sustaining. If I render this anywhere, server or client side, the component, like in React 18 and Suspense, but with React 17, the component will get its own data, server or client side, serialize it into next data, and if it already exists when the app starts up, it won't re-download it again. So it removes the network duplications as well. So with federation combined in here, it makes it really perfect. So I can go over into my app, and now what can I break? What can the header break? I don't pass it props. I don't give it data. I just import the header and render the header, and the header is completely self-sustaining. It can be put in its own error boundary, and then if something breaks, there's no way that it can crash the application. How that import looks is basically it's just cool, import home/header. I could also require it synchronously, or I could, import from or do a top level await. So all these methods work. Now I'm just using Next Dynamic. So I've already changed it to green. I hit save, and you see it say, cool, it emitted here. Now I haven't restarted anything or anything like that. I'm going to jump into my browser window here. It's still red. And how I perform my hot reloads is to try and make it performant. So I'm following Cloudflare's processes, which is stale while revalidate. So if I deploy a new remote, how do I inform all the consumers of the remote that it was updated? You could use Kafka events. You could do SNS. You could, you know, create the infrastructure and communication buses around it. For me, I really don't like having to do all of that extra work and maintenance that I don't really understand. Like, I just want to write JavaScript and it work, and I not need events and orchestration and buses and all of that. So what I do is I pretty much stale while revalidate it. So the remote's been updated and it's been rebuilt or redeployed locally here. I'm going to hit this page again. It should still be red, but see down here is it goes, cool, it rendered the page. There's the home, there's the nav data. So I console log it out of header. So now I can see in home, it actually printed out the JSON that the header fetched its own data without hooking up to get initial props. And then you'll see down here, it says the home hash is different, must hot reload server. So after I send my response, I revalidate all the remotes that I have and check, have the remotes been updated? If they have, on the next step in the event loop, I will hot reload the server, which means that I'm not blocking traffic coming in. It's always performant because I'm going to send what I've got and check in the background if I should hot reload. If I need to, I block the event loop and hot reload, but I don't disrupt the traffic flow of the current request. So now I'm going to hit it one more time. And now it's green because it saw that the hash had changed and it hot reloaded itself on the next invocation. And now everything after that has the updated code. And this is server and client side. So if I were to go and view the page source in here, I should be able to see, come on now. I might have missed it. Yeah, background green. So see, it actually server-side rendered the new update. So I'm just going to copy this class so that I can find it again when I do the next reload here. So now we're going to go back into the header. I'm going to change it to red again. Oops, I'm going to change it to red. Cool. My one server built, the home app rebuilt itself. I'm going to come back over here, refresh the page, still says green. Home is different, must hot reload server. And now it's red. And again, if I come here, it is now red. And so, you know, and I can do this, you know, with any application anywhere in the stack, I can, you know, do just as easily. So if we want to try pushing something out to my production environments, let's go for it. Just trying to think what's going to be the quickest way to do that. I'm going to go over to independent remote. So let me just check where I use independent remote so that we can go and see where. Okay, so it's going to be on the home page. So the home page is also not part of checkout. So when I'm landing on this page, this home page doesn't exist. So the nav doesn't exist in the checkout app. This home page doesn't exist in the checkout app either, yet it's server-side rendering it. And each one of these is a different remote container coming from a different application as well. So there's like maybe 5 remotes that build up this page, and I'm streaming the code in just like you would do in the browser on the server as well. So if I go over to, let's see, so there's other component, and we're just going to see, let's see, so I'm going to go over to independent remote, and I'm actually going to deploy this out to the production environment. So I'm going to go in here and just look for outside component. And now we're going to say, hey, everyone, thanks for joining my Google Meet. Okay, cool, boom. So I've done it, all good. I'm going to commit this. I'm going to push this. And now Versal is going to start compiling and deploying independent remote, which is a complete its own next instance, its own next server on its own. I'm not even going to, and now locally here, what I'll do is once, you know, let's give it 60 seconds to let it build, but then I'll refresh it here and we should see this remote change because this is only wired up to the production one. There is no local host for this. This is coming right from production. And what I'll do in another tab here is I'll get up the, hold on, let me jump and get the URL from here. Cool. So then what we'll do is in this window, we'll just go ahead and load the checkout application, which is the one that we see here. It's still green like before, and you can see it still says that. So we'll give it a minute or two to go and do the Vercel deploy. And yeah, so let's give it a couple more moments to run that deployment. In the meantime, I will pause for a moment and check if there's any other questions. I can't see my screen if somebody has a hand raised or not. So yeah, I'll pause there for a moment and see if anyone has any questions. Or yes, Clifford.
I was curious about, so I know that you're working on you recently published a like a package for Next, I think, and also are you working on any content that will bring more people up to speed with this style of application development? Because I know that there's a book that you showed, and I also recently just bought it, haven't dug too deep into it. But I guess, you know, if the answer is no, I know you're a pretty busy guy. Who are some folks we should people that we should follow? I know you're one of the folks to dig in after, you know, after we see some of the stuff you're working on, or a little homework, if you will.
Yeah, so in module federation examples, I do have a really dumb sample of this federated Next, so one for SSR and one for client-side rendering. I am going to try to put together like some course material or something like that, like maybe a video course. I also do offer workshops in person or virtually with companies. And then I also have a fully staffed consultancy firm if a business is interested in, you know, wanting help in architecting these type of applications or stuff like that. And then I'm definitely going to try and work on the content because beyond the technicalities of here's the plugin, it works, it's, well, how do you think about designing software built for distribution at runtime? What are those patterns, stuff like that? I would say the biggest space that I've got, if you want just general federation stuff, it would be the Practical Module Federation book that me and Jack Harrington wrote. I'll probably add a chapter on about Next.js and potentially about SSR as well. And then I will probably try to work on some content and publish it out to Medium. And then, yeah, you know, I'd love to get together like a video course or something like that where I can really go in depth and we can do some more advanced pieces or cover a larger amount of the landscape. But those would be the suggestions that I would post out there. Is check my examples repo, my Twitter, my Medium posts. Jack Harrington's another good source. Tyson, he's the one who wrote Aegis. He's also a good source to follow on this. And then, yeah, I'll be working on trying to get more content out there and, you know, more engagement, more educational material so that I can spread this knowledge among others.
Perfect, thanks.
So while I was answering or you were asking that question, I don't know if anybody saw, but it says, hello, everyone. Thanks for joining my Google Meet. And that's on the checkout app. I could go to the shop app as well. I haven't gone to the shop app in a while, so let's see if it still works. I could go to the shop app, fingers crossed. Cool. Oh, the shop app doesn't use the same one. I haven't updated it in like 3 or 4 months. I can go to the home app and it should have this update. Yeah, and you can see here the home app as well. And remember, independent remote is not shop, checkout, or home. It's independentremote.vercel.app. So this is coming from a completely independent build, a completely different repo that can be deployed separately. And I mean, you saw it took like a minute and the code was immediately up to date. We can go and do it again just because why not? Test 1, 2, 3, 4, 5, and we will push this out to Versal again. And so the trick on how this mechanism works is there's a few ways you can hot reload an app. I had struggled to figure out what the right way to do it is in development mode because everything gets stored in memory. So it's harder to hot reload, it's harder to hot reload node the way that I need to in development mode, because in dev mode, there's no socket connections connected to independent remote. It's running in production mode. So how do I let something know that some change has gone off and happened? So hot reloading federated code in general is tricky. Doing it on the server is close to not possible, but we've been able to do it in development and at server time, and it's pretty quick. I mean, you can see here on localhost, I'm just going to refresh it here to see when the new testing thing comes through. So we'll just keep doing it. It'll take probably like another minute or so before it fires up. And in the background, watch my terminal and you'll see it tell me some remote has changed as soon as the deploy takes hold. So I'm just going to keep on sitting here and doing it just so you get a feel for like how long it actually takes to do this. And of course, this is dependent on how long CI takes to come up and, you know. Okay, there we go. The hash changed. Now the deployment is up. The next refresh will have the server-side code done. Test 1, 2, 3, 4, 5. I'm going to come over here. I'm going to hit enter the first time. It's there, but you still saw that flicker where the HTML wasn't updated. And if I hit enter again, it is now properly updated. And if I go and view the page source here, it should be able to go 1, 2, 3, 4, 5. And there you go. It's in the HTML. So now that's 2 times I just deployed to production in about 90 seconds. And if I go back to my, my checkout application, you can see the last time it was ever deployed was 20 hours ago. So we've just updated production twice, yet I never tore this Lambda down or did anything to it. Yet my response times are still unimpacted here. So if I go and look at the production one, pop open my DevTools here, and we can go and just look at our network. And if I refresh the page, with my cache disabled, it took 513 milliseconds for me to render this application. That's a full end-to-end load, and this app has got 5 or 6 remote entries on it that it has to stitch together. So 5 federated modules that have to be streamed from the server into the runtime there to be executed. Then I have to do the same in the browser to hydrate everything. And I did all of that without a browser cache in 500 milliseconds. So with a response time of 141 milliseconds. So that's pretty good if I don't say so myself. So the last thing I want to show is that we can turn off the Versal cache itself and say, go invoke the Lambda directly. This one ought to be a little slower because now we've got no edge caching in place and we're causing a full invocation. But even so, it was still 1.4 seconds, and that's how long it took to respond. That's on the checkout route. Let me go to the home route again. And we'll see how long it takes on our home route. Yeah, so there we go. Still 1.47 seconds. So that's on a cold start, invocation, stream all the code from 6 different remotes into that Lambda's runtime, send that to me. It was all done in 1.4 seconds. The full page load. So that's pretty quick. So you can imagine as things are getting patched and pushed and updated everywhere, from this kind of demonstration, you can see that this is all uncoordinated. I don't have to redeploy anything. I have no installs I have to go and update or change or do anything like that. Yet the whole application looks, feels, and works like a monolith. I can still go to the checkout route and there won't be any page refresh to go here. I can go back to the home page, which doesn't exist. It's using module federation, and the whole application still looks and feels as if I was using a single page app. And, you know, I can say go, I don't know if accessories works. Yeah, I can go to accessories, go back to home, And all of these are different remotes. This is the shop app. This is the checkout app. And then the home page is the home app itself. Yet no page refreshes at all. 3 independent applications stitched together, with the home page consisting of an additional 6 remote entries with nested imports, all of it server-side rendered, all in under 500 milliseconds end to end. So anyway,
I think Mohammed had a quick question. I don't know. It's not like Twitter Spaces where a hand goes up, but he raised his hand.
If you've got a question, just interrupt me by all means.
Yeah, this is awesome at first. So great to see. And my question is, the remotes are basically has a cache header, right? A stale on revalidate or something like that, or for the hot reload, I mean, because it seems it worked like it has some cache headers. You know, you first one time reloading, and the second time it's going to build, and then when you are watching it again, it's now you see the updated content. Is it the cache header or is some magic behind the scene?
Magic behind the scenes. So remember, how I try to build everything is, and maybe to my own detriment, but my view of the world is I don't need anything other than Webpack and some CDN. Like, I don't want infrastructure. I don't want to have to deal with cache headers. I don't want to have to deal with anything other than just writing an app and deploying it. And I want Webpack to be my ingress. I want Webpack to be my Route 53. I want Webpack to do as much as possible, and CI to just put stuff on the internet, and have Webpack manage as much infrastructure as possible and do as much of the ops as possible through orchestration at runtime. How do I invalidate it without headers or anything like that? I can actually show you. So if I jump into here,
you mean you mirror, or you're inspired by the stale on revalidate to not be like the network, and it seems like it,
it's
but
the
it's
concept.
not.
Yeah. So I'm using the same. I could do it up front and say, well, when a request comes in, revalidate, and then hot reload and serve the result back to the end user. But I would prefer not to slow down the user and say, cool, send what you've got that's in memory, and in the background, without impacting performance, then go and check if you need a hot reload. So how that works, and you can change it easily, is inside of get initial props of document, I just go ctx res on finish. So when I finish sending the response, I go then revalidate. So after I send a reply to the end user, I'll revalidate, and the revalidation function is hooking into Webpack, gets all the remotes connected to the graph, and is really primitive, and just goes out and gets the MD5 hash of every remote connected to Webpack currently, and it compares it to the previous hashes that it has for those key value stores. If the hash is different on any of them, it'll immediately exit getting any other remotes, and it'll perform the hot reload. You can also do additional things, like say you want to have, you don't want to just hot reload it in memory, but you'd prefer something a little safer, like you don't want global scope to be poisoned by code coming in. Then another tactic you can do is you could say, okay, well, don't just hot reload and clear it, but instead I could say, okay, let me rather go and say, okay, well, once you've sent a response, I want you to kill this Lambda, and then make Amazon pay to cold start a new Lambda for you, instead of you having to terminate a worker and boot a new worker, which counts against your computation time. If I kill the Lambda, it'll force a cold start, and Amazon has to pay to bring up a new worker for me, not me. So I can do that if I want, to mitigate blast radius, or if somebody poisons the global scope for whatever reason, I can have a bailout system where I go, it looks like the scope's been poisoned, I'm going to terminate this Lambda and make Amazon start a fresh one. But in ideal circumstances, I just say, cool, revalidate, keep everything hot, keep it always on, always warm, and never force the process to shut down. unless you're running like a Kubernetes cluster or some kind of persistent server system where you can tear down a worker and you already have workers in the background in a pool who are ready to take over the load. Then it's really useful to say, okay, well, when you send the response, if you need to revalidate, just kill this one in the cluster and let all the traffic go to the rest of them. And each of them can programmatically, do a kind of rolling restart in your server cluster. But if you're in a serverless environment, what are the options? Do I force a cold start on everybody? Or, if you trust the application and it's all built to spec, it won't poison the global scope, and I don't need to do any process termination or any expiring, and I can simply just tell Webpack to restart itself, not restart the server. And then the chunk cache is cleared, Webpack's going to restream code that it needs down, and you can see in here it's going, cool, will load chunk, and it's pulling down other thing, which is from independent remote. That's where independent remote is coming from. So you can see in here that it's saying will load chunk independent remote SSR, whatever fed. So you can see it in here as it's streaming code back and forwards between my servers. And whenever I do a hot reload, it's going to restream this code with the latest update in it. And so, yeah, so that's what inspired it, is the concept behind stale revalidate. But I could also just do something like this and just say await, revalidate, and then go and get initial props. And then this will reverse it and say, cool, hot reload it, check if you need a hot reload, do the hot reload, and then respond to the request. But I just want it to be quick. So that's the only reason I use
so cool.
it on finish.
Yeah, this is so cool. But I don't know if it is a problem or you're solving it. Or, for example, if there is a Nginx in front of all these remotes, and you're hitting, for example, for a asset like here. For example, you're hitting for underline next, static, some assets. Then the Next.js is confused to, then the Nginx is confused to load which one of these assets.
So I had to solve this problem already because this was a real pain in the butt to solve. So in the browser, when you use module federation, we usually tell you make public path auto. What that does is it means that Webpack will look at where its runtime was injected. It'll go document.current script source, pull the public path off, and get what's the asset prefix from where you embedded Webpack to start with. And then it uses that asset prefix from Webpack, the Webpack runtime itself, and it knows that that's where all the rest of the chunks are going to be located under there. So I don't need to know what my assets are everywhere. I just need to know what's the URL to the remote, and I've rebuilt the public path auto convention inside of the server. So if I have different asset paths or whatever, Webpack will do the same thing it would do in the browser on the server. So it could not come from _next. It could come from any other pattern or deploy convention that you want. And how you control that is just inside of your next config, is inside of here. I can say, okay, if I'm in Versal, use the Versal base setup. And then I've got a parser in here, which will find what's the asset prefix. Is it set to next or whatever? Then it'll go and strip this out, get the server-side location for the code, use this to replace the remote entry with, components header. So then all I'm saying is, cool, it's static SSR, and now it's, components header TSX fed. And I just remove remote entry, and I now know, cool, this is the asset location for everything. So if I have it sitting in front of Nginx or anything else like that, these URLs can be anything that you want as long as it points to wherever your remote entry is. And then it'll use that for everything else that you want it to get automatically. And the only URL you need to know is, how do I get to the remote entry? If you know the URL for the remote entry, internally, I will know how to find all your chunks by calculating the asset prefix based on the one known variable I've got, which is where the remote is located on the internet.
Oh my God, this is so awesome. My solution was to write a wrapper around the next image and, prefixing with the asset. Again, now the client links, broke, and I wrote another wrapper around that, and, kind of changing the build ID from the Next.js, and wow, those are real pain
Yeah,
so many problems are fixed.
It's definitely tricky to do. The other issue that you could run into is, since I'm just getting remote entry JS, I had to build into Webpack a way to always cache bust the remote entry, so the browser doesn't hold on to an old remote after I've just done a new deploy, because I don't have any hash on here. It's predictably known. So I have Webpack. When Webpack goes to inject this, inside of the Webpack runtime, it adds a query string onto the end to force the browser to cache bust it on its way to the user as Webpack is controlling the injection process. So that guarantees me that the remote entry is always going to be cache busted. I do have ways where I could use a build ID, hash this, and then based on if it's server-side rendered, I could pull out what the remote entry's build ID is and inject that remote with a hash on the end instead of using the query string to cache bust it as well. So this is where, and I'm going to develop this into the plugin as a next step, because right now how you configure my plugin is you give it this syntax. You give it the @ syntax that I call it. If anyone doesn't know, the @ syntax is essentially global scope name at location. So what is it? Is it window home? Is it global this home? You know, what's my scope? What's the name on the scope that I can find it as? And where's the location I should resolve it? So I'm going to take this half, require it, inject it, evaluate it, execute it, do whatever I want. Once it's executed, I then know what it's called in the namespace so that I can reference it. So usually you see a one-to-one match. I call it home, and in here it's called home. In reality, it could be, you know, home could be this. Bananas, window.bananas. No difference to Webpack at all. I've now made the map. So the alias inside of my app is import home/whatever, but I could resolve it to window.bananas or window.abtesthome_a. And then the middleware thing that I'm going to write is basically, we have a syntax called promise new promise, which is, I give it a resolver, and then I'm just going to change this to template string so that I can type a little quicker. So promise new promise is to tell Webpack, hey, there's no script URL, there's no path. Instead, it's a custom promise, and what I'm going to resolve the global for you. So I could then just, you know, I could basically make it up on the fly and resolve a fake remote container. So like if they're not authorized, I could just have it resolve every get to a React element that says not authorized and not actually expose any real code. And so in promise new promise, what you could do is you could say, okay, let's just say we're going to say inject JS. And then you could say, okay, URL. Then I can go like this and say, okay, cool, I've injected the script or I've done whatever I need to do. And now I can go resolve. And then it would just be window, you know, assuming that it's the remote entry and its name is home, then it would be resolve window.home. So now you can programmatically control it, which means before I even get here, I could do something else like, you know, let's say get auth JWT, then, and, you know, basically I could chain onto it. So to say, yeah, but, you know, you get what I mean. Like I could basically say, okay, go check their authentication token, then inject the JavaScript based on their role or whatever, and then resolve the injected container back to Webpack to use as the remote for whatever I'm doing. So it gives, so the case I used it for at work recently was I need to get the environment variables that are publicly exposed. Usually those are rendered in Next.js in the document. But if I'm running someone else's code inside of someone else's app, I need a way to, before I even try and run or load the remote, I need some kind of middleware where I can say, get the environment variables for this remote, inject them into the system, and then allow Webpack to resolve the remote container and start requiring code from another location. So what I've got at work is basically similar setup here, but inside of my plugin, I have go get env vars, and then what I would do is I would, basically I have like a config map or something in sort of the environment variables, or, I get it from the code that they give me. So nobody writes any of this. What they do is they just give me this URL, and then I can interpolate who they are and where I need to find whatever I need to find based off of this known URL. So similar to how I get all the chunks, I can also figure out what's the API route to their public environment variables. So I can say, go get environment variables for home or whatever, then, and let's just use await because that'll be easier. So go get environment variables will inject, hold on. So go get environment variables will get the home page's public environment variables that are usually in its document, will inject them into the window. Then I can go await, go load remote. And then I would pass it, the original container, like, or HTTP. And then I could say now resolve or res, and then it would be, window.home or whatever else that I want it to be. So the nice thing is you could also have it be something different, like what if you want to say control the versions at runtime and do runtime versioning? So what if I have multiple versions of the app and I want the checkout app to be locked to a certain version of the homepage? Well, you could use something like the product that I've got called Medusa, which is basically a UI connected to every federated Webpack container attached to your network. So what happens is in Promise New Promise is they go ask Medusa for remote, and then in there it will just say I give it the current app. So I am checkout and I'm looking for home. And then what Medusa will respond with is going to be config, which is going to give me two things. It's going to be, then I can go, okay, then inject script, which is going to be config.remote container URL. And then I would go, then once I've injected the remote, I can now resolve it with Medusa as well. And then I would go resolve the Promise New Promise resolver. I would go resolve config dot remote global namespace. So now I could deploy, now with this kind of setup, I have a lock file for every single federation thing in place. So if I have a pattern library or a design system, the header could use the design system and so could the homepage. And they could both use different versions of the same remote without there being any kind of collision or anything like that, because they're all namespaced differently and I'm controlling them all with this Promise New Promise type middleware. So anyway, hopefully that gives you a bit of a peek inside of my application design.
Nice, thank you.
So yeah, anyway, so I've probably got to run soon, but if you have any questions, I'll do 10 more minutes if anyone has any other questions.
I have one question about, so you're running this in, well, your particular example, you're using Lambdas. Is there something very significant in terms of the setup when you're using long-running servers? Like, let's say you work in an environment where you're not going to be able to use Lambdas, at least maybe to start off with. Yeah.
The design of this system is it works on anything capable of running Node.js. I use Lambdas at work, so of course I'm building everything so that it works in serverless, but the design principles of it, it'll work on any compute primitive, on basically anywhere Node can run, this thing will work. Persistent systems like, bare metal or Docker containers are a little bit nicer because then you can actually store information for longer. And you don't have to worry about it being so ephemeral. So I prefer containers because it's even better for software streams. But it's not limited by any means. It'll run on anything that node can run on. Your computer, bare metal, containers, fly.io, AWS, you name it, it'll work.
You mentioned one thing about containers, so versus like I guess not having the option of containers. So where I work, we're picking up on containers.
So bare metal.
Do you think? Okay.
Yeah, like basically you have a node box and you push everything to that box, but there's not really an image or something for it. It's just a node box somewhere.
Yeah, you said one thing about containers, them being able to, I guess, more stateful information, being able to leverage that. I guess I wanted to touch on what you meant by that, I guess.
Yeah, so the nice thing with the container and EC2, or pretty much something that's always running, is if my Lambda goes cold, I have to stream the remotes back into it because they're not on disk. This is using software stream, so I'm streaming the common JS that I need from other, ideally like behind a protected root or authentication token, but I'm securely streaming code in between independent systems. If the Lambda goes cold and I wake it up again, it's going to have to stream the code back down. What you saw when it was cold, it only took 1.2 seconds to reply and fully load. But if you're in something that's always online, I can take those remote chunks that I got in or the versions of them, and I can just put it in memory and it'll always be there. If I hit it an hour later or 3 hours later, it's never going to go cold unless I do a redeployment and restart the process. So it's great because it's more persistent. So it's even more performant then because it's always warm, and you can build up, more complex storages of these things. Like I could hold multiple versions of the remote, and if something failed, I could have Webpack automatically retry with a previous version of the remote entry that's already in memory instead of on the Lambda where I'd have to catch it and then cycle it through again and restream a different piece of runtime into that Lambda because I don't have any persistent storage available.
Awesome, thanks. That sounds freaking awesome.
Cool. Anybody else?
Like maybe one final question for me. We are separating our desktop and mobile environment because of some people are doing like m.site.com or something like this. And my question is, from my experience, couple of pages like have problem and have problem loading the JSON of the JSON for the page. For example, they got 404 for the page. And is module federation gonna help us, for example, separating mobile and desktop, or just no, module federation is not for that?
Module federation, so remember, module federation is not a framework. Module federation is basically like symlinks on a file system. It will let you load code from something else that was deployed independently in an uncoordinated, unorchestrated pattern. How you choose to control it and what you want it to do in the event that something doesn't exist, the side effects are handled by you. What I would say, though, is federation gives you a lot more power. Like if it doesn't exist, it can try something else because the remotes also can accept an array. So it can try origin 1, origin 2, origin 3, or you could send it promise new promise and redirect it out and bounce it out if it doesn't know what to do, or give it like a fallback state like a 404 page. But it gives you multiple ways to try and deploy or find something, and it gives you a very elegant way to try, catch, and handle it, other than hoping that the JSON still exists, or you're not depending on API calls and network the whole time. You're more dependent on like static assets, which typically are always there, and they rarely go missing. If your server restarts, you don't really have to worry because you're deploying JavaScript. So that's usually not vended right from the server. It's usually on the CDN. So it gives you a lot easier ways to self-form and orchestrate it, because you can do retries, try catches, and you can also just sit and wait for something. Or if for whatever reason it doesn't work, you can elegantly handle the fallback smoothly.
Right, great. Thank you.
All right. Cool. I will leave the floor for one more question, and then, for anyone who's just joined, I will put this up on Twitter, this recording up on Twitter, so you can watch the whole little demo and chat. Awesome. All right. Well, hopefully you got to see some cool things, and thanks for joining. I'll try to give more notice on the next one.
Thank you.